one last thing that we can look at. One thing that we often will look at when we're dealing with solubility equilibrium is whether or not the combination of two solutions will result in the formation of a precipitate, especially if those two solutions contain an ion, anion and cation, which combine to form an insoluble salt. So, for example, and we'll know that a precipitate will form if the concentrations are above the solubility. Okay, and if I have a supersaturated solution. So a quick method of checking is I could calculate what we call a total ion product, or QSP, and compare it to my KSP. And if my total ion product, or QSP, is greater than my KSP, then my system's not at equilibrium and I'll get a precipitate. If my total ion product, or my QSP, is equal to or less than my KSP, then I will not get a precipitate. So this is similar to our reaction quotient, where we will take the concentrations of the ions and see if, when we substitute them into the calculation, we get a value greater than our KSP to tell us which direction the equilibrium will shift. If there are too many ions in solution, my system will shift left, causing the formation of precipitate. If there's not too many ions in solution, then it would shift right, or would not shift at all, and I won't get any precipitate. So let's take a look at an example. So I'm going to combine 100 milliliters of 0.1 mole per liter potassium sulfate with 100 milliliters of 0.1 mole per liter lead 2 nitrate solution. And I want to know if a precipitate will form. So before we dive completely into it and look at the total ion product and see if a precipitate will form, we first have to go back to our grade 11 knowledge, and we'll write out our balance equation. And then from this balance equation, we have a lot of extra information here. So what I'm going to do is I'm going to solve for my net ionic equation, and for my net ionic equation, I can get my equilibrium expression. Now, I know this equilibrium expression because I can just look at the combinations that will result in a precipitate. Since this is my insoluble salt, I know that that will be the one that establishes my dynamic equilibrium. Now that I know my equilibrium, I can determine the concentration of the ions that are present initially. Now, this is where we have to be careful. I've combined two solutions together. And so therefore, what happens is I cannot take the concentrations as listed, but I have to apply a dilution, where my concentration of my sulfate is equal to the concentration of the solution that provides the sulfate ion times the mole ratio. So that would give me how many moles per liter of sulfate was present. And then I have to apply the dilution. So this is C1V1, C2, V2. And so I can get my initial concentration of my sulfate. Similarly, I have to do the same thing with my lead. C1, V1, C2, V2. So the concentration of lead ion after dilution is equal to the initial concentration of the lead ion times its volume divided by the total volume. Now that I know the concentration of my ions initially, I can now write my QSP expression and substitute and solve into it. Then we can compare it to my KSP, and since QSP is greater than KSP, a precipitate will form.